This video will be about the measures of central tendency, or mean, median, and mode. The one you've probably heard the most often is mean, and they often use the word average. That means the same thing. And this is best if there's no outliers. So an outlier is when there's one number that's just clearly not belonging in the data set. You know, if we had a data set of 5, 7, 3, 8, and then 50, 50 is way different than all the rest. So 50 would be the outlier. The median is the middle number. And it's best if there are outliers. And what it's going to do is it's going to split the data into the lower half of the data and the upper half of the data. So we'd have to put the numbers in order. 3, 5, 7, 8, then 50. And we want the middle one. So I usually go from each side in, cross out one on the left, one on the right, one on the left, one on the right, until I get to the middle. And that is the median. And then the mode is the number that occurs most often, and it is possible for the data to have no mode. This particular set of data, there's nothing that repeats, so there is no mode. And it's most useful if you're going to try and find like an item that's most popular. So if you have a lot of data and they're describing a real life situation, finding what's most popular is when the mode is most useful. So sometimes they do give you a large amount of data. Sometimes it's hard to keep track of. So when you have a lot of numbers, if we're going to find the mean is adding them all together and dividing by however many there are. So let's count how many numbers there are first. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 numbers. So then we are going to add all of the numbers together, every single one on the list. I'm not going to write them all out, just the beginning and the end. If we add them all together, that gives us 235. Then we divide by the number of numbers. There were 15 numbers there, so 235 divided by 15 is 15.666 repeating. Let's round this to the nearest tenth, 15.7. Median, we showed an example on the last page too, but when there's a lot of data, it's sometimes hard to get them in the correct order, but it is better to put them in order rather than try and just look at the data. So we look for the lowest, which is 5. Next comes 2 8s, and as you're going, it can help to cross off any numbers you've already used. Then we have 9. We don't have a 10, 11, or 12, so we have 13. Then 15, 16. 17, 18. Next is 19. I'm going to go to the next line because I'm running out of room. 21, 22, 23, 24, and 26. 21, 22, 23, 26. Okay, once you're sure you have all the numbers, you can find the median and the mode. Before I cross them off, I'm going to check out for the mode. Mode was the number that occurred most often, and the one that occurs most often is these 13s. There are 3 of them. So then, again, I just cross out one on the left, one on the far right, one on the left, one on the right. And I keep going until I get to the middle. So then our median is 15. Occasionally with the median, if we had one less number, like if we didn't have this 26, then when we go to cross things out, we end up with 2 numbers in the middle. 4, 5, 6, so we end up with this 13 and this 15. If that were to happen, you average those 2 numbers to find the median. 13 plus 15 is 28, divided, there's only 2 of them, so divide by 2 is 14. So we're going to have to apply these to real-world situations, and they're going to change how you're using them a bit. So Alex wants to make an average of $60 a week mowing lawns. The data for his first 5 weeks of mowing lawns is in the table below. So it shows us the weeks, how much he's making. How much would he have to make in week 6 to have an average earnings of $60? So they gave us 5 weeks, and they want us to find week 6. They don't want us to find the average of what we already have. They told us the average. The $60 is our average. So there's a week 6. I'm going to write over some of these words. A week 6 that we don't know, I'm going to put X for the number we don't know. So if we were to average all of these together, we would have the 50 plus the 75 plus the 80 plus the 45 plus the 30 plus the number we don't know, all divided by 6 because we did it over 6 weeks. And that would tell us our average number. But we've got to go and do this process backwards. Instead of getting our average from dividing and adding all that, we're going to do the process backwards. The last step was to divide by 6. Well, we're going to take our average and multiply by 6. We're doing the opposite direction. That gives us 3. Then, still doing this process backwards, we had originally added all the things together. We need to take this number and subtract everything else from it. Subtract the 50, subtract the 75, 80, 45, and 30. When we do all of that, we'll get our week 6 number, which is how much Alex would need to earn so that he has a weekly average of $60. When we subtract it all, we get 80. And you can do it by hand, but it's better to use a calculator. Another way to approach the average is to group the like things together. So this one is shoe sizes of 22 adult women, and they're recorded in the table. But there's 2 women with a shoe size of 5, 3 women with a shoe size of 6. So really, if we were to write this out, we have 2 5s, and 3 6s, and 8 7s, so we get a very large amount of data. But if they're grouped together like this, instead of having to write out 22 things, we can approach this a little bit differently to find the average of all the shoe sizes of the women surveyed. So, when you add 2 like things together, 5 plus 5, that's 10. That's really the same as multiplying. Multiplying came about from adding the same thing together over and over again. So 2 times 5 would be the same as doing 5 plus 5. Or 6 plus 6 plus 6 would be the same as doing 3 times 6. So we're going to multiply all of these together and then still add them together. So 2 times 5 is 10, 3 times 6 is 18, 56, 40, 27, and 10. And then if you add them all together, that is 161. So then we have to divide by how many there were total. You could either add up all the number of women, or they told us in the beginning that there were 22. So we divide by 22, which gives 7.318. The 18 repeats, but we're going to round to the nearest tenth, so 7.3. That's not an actual women's shoe size, though. So sometimes they may round. They could still say the average is 7.3. On our chart, we didn't even do half sizes, so they may round this and say, well, that's approximately a shoe size of 7, just because we are applying it to a real-life situation. The last one's going to compare 2 different sets of data. So the monthly profits over 6 months for 2 different stores are listed below. Store 1, Store 2. We want to find the mean and the median. It asks a whole bunch of other questions, but let's just start with that. Let's find the mean and the median. So mean we know is adding them all together. So for Store 1, that's 38,500. And then divide by the total. There are 6 months total. That gives us 6,146.666 repeating. I'm going to round to the nearest whole number since all of our amounts were by whole numbers. So 6,147. Then the median for store 1 would be the middle number. They're not in order, but there's few enough data we could probably find this ourselves. So the lowest was 5,000, highest is 7,500. The next lowest is 6,000, next highest 7,500. So we are left with two numbers which we have to add together and divide by 2. 6,000 plus 6,500 is 12,500, divided by 2 is 6,250. Then we look at store 2, we do the same thing. If we add them all together, that gives us 36,250. Divided by 6 is 6,041.666 repeating again. And I'm going to round to 6,042. We can find the median now, lowest and highest cross out, second lowest and second highest. So we're left with 6,250 plus 6,500, which is 12,750 divided by 2 is 6,375. So then they ask us a couple of questions about this. They say, which store has a better profit according to the mean? So the mean, then store 1 has the better profit. They made more overall for this average. What's the store? Which store had a better profit for the median? So for the median, then store 2 had a better profit. So definitely looking at the different measures can have different results. And why that may have had a different result is whether they had outliers or not. So then two last questions about this. First is, what is the difference of the means? Difference is a fancy word for subtract. So we're going to take the bigger one, 6147, and subtract 6042. That gives us 105. That's the difference in the means, and then also the difference in the medians. So we pick the higher one. Even though store 2 is higher, it was second, we still put it first when we do our subtraction. So 6375 minus 6250 is 125. So there was more of a difference in the medians than in the means. So that concludes our discussion of the measures of central tendency, or mean, medians, and mode.